Assalamualaikum warahmatullahi wabarakatuh. Hello guys, welcome back to Engineering Work System and Ergonomic Tutorial with DSKE Laboratory. For today, we will discuss about manual material handling. But before we start, let's pray together. Pray start. Finish. Let's start the tutorial. As you can see in the illustration, there are some people moving their household furniture into a truck. When they are moving the goods, of course, they will carry out lifting and lowering activities. So, lifting and lowering activities here are one of several activities in manual material handling. If lifting and lowering is done repeatedly and in the wrong way, it will be dangerous for the people or the person and can cause a low back pain. So, manual material handling is an activity of lifting goods manually carried out by humans. With the application of manual material handling, we can calculate the value of the load limit that can be lifted, so that later in the lifting, we can find out how to lift the objects better, the load limit that can be lifted, and the safe distance to carry out the lifting. Okay, now for the purpose of the tutorial, there are four purpose of the tutorial. The first is you are able to understand the concept of the manual material handling. The second is you are able to know the load limit that can be lifted by the workers, or it can be called as an RWL or recommended weight limit. The third is you are able to know the classification of activities of the manual material handling on workers, or it can be called as lifting index. Then the fourth and the last one is practitioners, or you are able to provide the recommendations to the workers. Okay, for the explaining regarding the RWL and lifting index, it will be explained in the next slide. For the input and the output of the tutorial, for the input the first one is operator data and design of the lifting activities. For operator data, as usual, you will explain the characteristics of the respondent or operator who carries out the lifting appointment, and then the design of the appointment in the form of a prefix layout design and also a proposed layout. Then the second is a video of lifting process. The third is screen captures of photos from the lifting process. And then for the output, the first output is the recommendation weight limit analysis, and the second is the lifting index of the work, and the third is the recommendation for improvement. For the recommendations, you will provide an analysis regarding the proposed layout. Okay, now I will explain what is manual material handling. Well, manual material handling is an activity that is included in the heavy cart category. It is considered to be included in the heavy work category because manual material handling is very high risk, especially to the spine or back of the people. The risks that usually occur if the method of lifting is wrong is like invertebral disc and interference with the worker's back. At the beginning, I have explained that manual material handling consists of several activities like lifting, lowering, and there is still other activities like carrying, throwing, holding, pushing, and pulling. But for the manual material handling tutorials, we will focus on lifting and lowering only. Now this is a guideline from NIOS, or National Institute Occupational Safety and Health, explaining that the manual measurement of the core material in lifting and lowering activities applies to certain circumstances as shown on the slide. The first is that the load given is a static load, so there is no increase or decrease in the load in the middle of the work. So later, when you do the data retrieval, you cannot add or reduce the load that is being lifted during the lifting process. The second is that the load is lifted with both hands. And then the third, lifting or lowering the object is carried out within a maximum of 8 hours, and this 8 hours is the duration of the observation, not the duration of the work. The fourth is that the lifting or lowering of the objects should not be done while sitting or kneeling. Kneeling here means that it is a lifting position where the knee is the support. So, suppose you are observing and the knee is in the direct contact with the floor. The fifth is that the workplace is not cramped. And the last one, the lifting should not be too fast and the position of the feet is not on a narrow or in the slippery surface. Next, okay, now I will explain about the recommended weight limit. In manual material handling, there is what is called the recommended weight limit, or so-called RWL. Well, this is a heavy lifting condition that can be handled by a healthy worker for a maximum of 8 hours of work and does not pose a risk of low back pain to the operator. When given this recommendation, the worker can work repetitively and for a long time. It is obtained by measuring the observed variables such as horizontal distance, vertical distance, then angel rotation, and so on as shown on the slide. Next, there is a load lifting position. When you do the data retrieval, you will make some position, which position is more or less accordance with the picture shown on the slide. From the picture, it can be seen that there are several variables which are symbolized by letters. The first is the variable h, or the horizontal distance, which is calculated from the center point of the body, or rather at the ankle to the midpoint of the hand. Then there is v. This is the vertical distance obtained from the center point of the lift to the floor. Then there is the A, or asymmetrical angle. This is seen from the movement of the shoulder to the right or left, or the position of the shoulder is standstill. Then there is C. For C, this is the clutch or handle of the object. Then there is D. D here is the distance between V1 and V2, or the difference between the two of the image. It can be seen that there is only the movement of objects from the initial place to the destination place. So that later, it causes the appearance of new variables such as H2 and V2, both where the activity occurs in proposed lifting layout. So later when you take the RWL measurements, you will take two RWL measurement for each layout, namely the prefix RWL and also the destination RWL, like that. Okay, now I will explain about the variables to determine the recommended weight limit. The first variable is load constant. For load constant, this is the maximum load that can be safely lifted by humans based on National Institute for Occupational Safety and Health, which is 23 kg. This is based on the demographics of the Americans or the Europeans. Actually, it is exist for Indonesians also, according to the Wulandari research in 2015. And for the Indonesian themselves, the load constant is in 21 kilos. But for this tutorial, This time we will still use constant based on Americans and Europeans. Why we use this? Because for the linearity computation, where there are provisions for it of this variable, which have been adjusted according to the Europeans as well. Next, there is horizontal multiplier. The horizontal multiplier is obtained from the value when you take the data and the value of h itself. It is the horizontal distance between the center of the body to the center point of the leaf, precisely at the midpoint of the hand when holding the object. In carrying out data retrieval, you will measure two h. The first is h1 and the second is h2, where a1 is when the object is at the initial place and h2 is when the object has been moved to the destination place. Now h has a maximum distance of 25 cm. Why does it have to be 25 cm? Because according to the researchers, most objects that are less than 25 cm away cannot be lifting without experiencing stomach problems. There is also vertical multiplier. The vertical multiplier is obtained from the v value when you do the data retrieval. The value of v itself is the vertical distance between the floor and the object being lifted. In vertical multiplier, you will also measure 2v in each layout. There is v1 and v2. v1 is the height of the object in the initial position, and the v2 is the height of the object at the destination position. Okay, now then there is a distance multiplier. For this variable, it is obtained from the value of d when you collecting the data later. The value of d itself is obtained from the difference in displacement distance between v1 and v2. For this d value must be in the range of 25 cm to 175 cm. So later when you do the data retrieval and it turns out that the difference between v1 and v2 is less than 25 cm, then the calculation will still be written as 25 cm. Next, asymmetric multiplier. For asymmetric multiplier is obtained from the value of a when you collect the data later. The asymmetric multiplier is the angle of symmetry of the rotation formed by the body on which the shoulders are supported. So whether the angle is formed or not, it can be seen from the movement of the shoulders. Now, for one's own rotation angle of symmetry from 0 degrees to 135 degrees, which 135 degrees is a limitation of one's rotation symmetry. Okay, now we move on to the next variable, which is frequency multiplier. This frequency multiplier is the average lifting frequency measured in units of lifting per minute. So later, for the frequency multiplier, you don't have to do data retrieval because it has been determined in the case study according to the code of each assistant supervisor. But if you want to know how to get the frequency value, you can use a table in this slide. Now I will explain how to read the frequency multiplier table. For example, in the case study, you have to do one lifting activities in 1 minute. Then the duration of the lifting activities work is 1 hour. Okay. The first step you have to do is to calculate the frequency value, which is from the number of the lifting activities divided by the time of the lifting. Based on the previous example, the lifting is just one time every 1 minute. That means that the frequency of the number lifting is divided by the time of the lifting is 1 divided by 1. Then it is equal to 1. So the number of the frequency is 1. Okay, now the second step is we determine the value of the duration of work. From the example, it is known that the duration of work is 1 hour, right? So you can see in the column of 1 hour. Now we have to know also the phi value, whether it is greater than 75 centimeter or less than 75 centimeter. We take for example that the phi value is greater than 75, then we can conclude that the frequency multiplier value is 1.94, like that. Okay, now for the next variable to determine the RYL, there is a coupling multiplier. For this coupling multiplier, it will depend on the items you are going to lift. Okay, for how to determine it, it will be seen from the type of clutch, whether the type of the clutch you are lifting is good, fair, or poor. Now, in determining the value of this multiplier coupling also depends on the value of V, whether it is greater than 75 centimeter or less than 75 centimeter. Now, it turns out that the item you pick up is in the fair category and the V value is greater than 75 centimeter, meaning that the multiplier coupling value is 1. Then you can just enter it into the formula to determine the ROL, or less like that. So what's the difference between a good, fair, and poor coupling? We will discuss it in the next slide. The first one is good category. For good category, it is divided into 2 points which focus on symmetrical objects and the second focus on a asymmetrical object. The first is for symmetrical object. The symmetrical objects in questions, namely objects is the shape of a cube or box, which is the object has a hand grip that can be categorized as a good category. Besides that, it must also fulfill the notes as shown on the slide. Example of such objects are a clothes basket or supermarket basket. The second, focus on asymmetrical objects, namely objects whose shape is less regular. Objects that are irregular in shape are said to be included in the good category if they still have a grip that is comfortable and easy to grip and also fit the notes as shown on the slide. For example, the dam looks like a small rice sack that has a finger holes, so it can make it easier to carry the rice. Next, the second category, it is a fair category. For fair category, it's also divided into 2 points. The first one is an adequate clutch. The adequate clutch is defined as a design grip that lacks an optimal design, and it also have to fit the notes as shown on the slide. Now the second point from fair category, the second is for an object that doesn't have a handle or actually has a handle, it is not attached or detached. So you have to make your fingers and wrist bend 90 degrees, which is also a fair category. The example is when you lift a cardboard. For the third category, it is a poor category. In this poor category, it is also divided into 2 points. The first is said to be included in the poor category if an object has a design that is less than optimal or difficult to handle. If it's not optimal, what is meant by the note below? Then, for the second point, it is an object which has a soft or non-hard surface. Okay. Now you can see in the slide, there are some examples of the 3 couplings category. For an example of a good category, there is a basket, and for a fair category, there is a cardboard, and for the example of the poor category, there is a durian. After we determine and found the value of recommended weight limit, the next step is we calculate the lifting index. In calculating the lifting index, you can later determine whether the lifting index performed by the operator includes risky lifting or safe lifting. For the lifting index formula itself, it is the load weight divided by the recommended weight limit. For the load weight value, it can be obtained from the data retrieval, which is the weight of the load lifted by the operator. Then, For the recommended weight limit, you will get it from the results of the previous measurement, where each layout will have two RWLs, right? Namely the prefix RWL and also the destination RWL. So later, to include this in the lifting index formula, you have to choose the smallest RWL value. Why? Because of the value, the smallest RWL is more dangerous. Then after you calculate and find the results, you can categorize the lifting index value into the classification like shown in the slide. Well, I think that's all for the manual material handling module. Thank you for your attention. I hope what I give to you will be understandable for you, and I believe you are learning something after watch this video. And if you have something to ask, don't hesitate to ask to the assistant in the tutorial class. See you there, and stay safe and stay healthy guys. Wassalamualaikum warahmatullahi wabarakatuh.